When you step into the world of free energy and over-unity experimenting, few projects are as exciting as building radiant and magnetic heaters. These devices promise to turn unseen forces into usable warmth without depending on conventional fuels or high-cost electricity. However, as fascinating as these experiments are, they come with a serious responsibility: fire safety. Energy converted into heat is powerful, but uncontrolled heat can destroy equipment, property, or even lives. That is why understanding and practicing fire safety is not an optional detail. It is the foundation of responsible experimenting. Radiant heaters, whether they use high-voltage pulses, coils, or plasma discharges, create intense localized heat. Magnetic heaters, on the other hand, rely on rotating fields or induction effects to generate warmth in conductive materials. Both systems operate outside the comfort zone of commercial safety testing. They are homemade, experimental, and unpredictable. This makes fire safety not only a guideline but a survival requirement. The first step is awareness. Fire risk is highest when heat builds up in areas that are not designed to handle it. Coils, magnetic rotors, or radiant panels can reach dangerous temperatures faster than expected. Materials such as wood, plastic, and even paper nearby can ignite with only a small spark or prolonged exposure. Awareness means knowing the points in your system that generate heat, monitoring them closely, and keeping all flammable materials far away from your workbench. One of the simplest and most effective tools for fire safety is proper insulation. Wires that carry current must be rated for the voltage and current you are using. Underrated wires can overheat, melt, and ignite surrounding surfaces. Insulation also applies to coils and heating elements. Ceramic, mica, or fiberglass-based insulators can withstand high temperatures far better than plastic or rubber. Using the right insulation materials reduces the risk of accidental fires caused by electrical overloads or radiant hotspots. Ventilation is equally important. Radiant and magnetic heaters both generate heat that builds up in enclosed spaces. Without airflow, even moderate heat sources can turn into ignition hazards. A well-ventilated experimental area allows hot air to escape and fresh air to circulate, keeping temperatures under control. Fans, vents, or even simple open windows play a critical role in reducing fire risk. Never box your experiments in tightly without giving heat a way out. Now let me ask you something engaging. Imagine your radiant heater running beautifully, coils glowing, energy pulsing, and then the temperature silently climbs inside the box where you housed it. No sound, no spark, just a slow buildup of heat until suddenly something ignites. How quickly could you respond? Would you have time to act? This scenario is not rare, and it is why fire safety must always come first. Fire extinguishers are a must. At minimum, a Class C extinguisher for electrical fires should be within arm's reach when working with experimental heaters. Some experimenters also keep a fire blanket nearby for smothering small fires without spraying chemicals that could damage equipment. The key is speed. Fire grows exponentially, and every second counts. Having the right tools ready can be the difference between a minor scare and a disaster. Another strategy is containment. Build your radiant or magnetic heater experiments on non-flammable surfaces. Metal tables, ceramic tiles, or concrete floors are far safer than wooden benches. Enclosures made from steel or aluminum not only support your system but also provide a physical barrier between hot components and flammable surroundings. By thinking of your experiment as a potential heat source that must be contained, you automatically reduce the risk of spreading flames. Cabling and connections deserve special attention. Loose wires, poor solder joints, or overloaded connectors are hotspots for sparks and overheating. Each connection should be firm, insulated, and rated for the load. Using heat shrink tubing, proper crimp connectors, and quality soldering prevents hidden risks from growing over time. Many fire incidents in experimental setups are traced not to the main components, but to overlooked connectors that quietly overheated until it was too late. Monitoring is another essential layer of safety. Thermocouples, infrared thermometers, or simple digital temperature sensors can help track the heat levels of coils, cores, and housings. Many affordable sensors can trigger alarms when temperatures rise too high. Monitoring is not about paranoia. It is about turning hidden risks into visible information so you can act before danger escalates. Let us also talk about overcurrent protection. radiant and magnetic heaters often run on experimental circuits that may draw unpredictable amounts of current. Fuses and circuit breakers are the simplest defense. They cut the power when current exceeds safe limits, preventing wires or coils from overheating. Skipping overcurrent protection is like driving a car without brakes. It may seem fine at first, but the moment something goes wrong, there is nothing to stop disaster. Placement of the experiment matters as much as its design. Conduct your work in a space free of clutter, with a clear exit path. Never trap yourself in a corner surrounded by potential fuel sources. Keep flammable liquids, papers, and fabrics out of the area entirely. If you must experiment indoors, use fire-resistant mats or shields around your setup. Outdoors, make sure wind cannot blow sparks into dry grass or leaves. Each environment brings its own risks, but thoughtful planning prevents accidents. Let me draw your attention to unattended operation. One of the greatest temptations in free energy experimentation is to let a device run overnight or while you step away. After all, you want to test long-term stability and performance. But unattended operation is the #1 cause of catastrophic fires in DIY projects. Heat builds slowly, insulation degrades, and by the time you return, the fire may already have consumed everything. Never leave radiant or magnetic heaters running without supervision. Battery safety also enters this discussion. Many radiant heater experiments use battery banks as a power source. Overcharging, short circuits, or poor ventilation can make batteries themselves a fire hazard. A safe and weatherproof battery box, as we discussed earlier, becomes essential. Lithium-based batteries in particular must be stored with extreme care, as thermal runaway can cause fires that ordinary extinguishers cannot control. In addition to fire extinguishers, smoke detectors should be installed near your experimental area. Modern detectors are inexpensive and provide an early warning that can save both your project and your property. If you are experimenting in a detached workshop or garage, consider linking detectors with a wireless alarm that can notify you inside your home. Early detection is your best ally against hidden dangers. Some builders go a step further and create automatic cutoff systems. These are circuits that disconnect power if temperatures exceed safe limits or if smoke is detected. Such systems may sound advanced, but even a simple relay triggered by a temperature sensor can cut the supply and prevent disaster. Automation in fire safety is not about convenience. It is about ensuring that safety continues even if you make a mistake or are momentarily distracted. Materials play a huge role in fire safety. Radiant heater housings should be made of metals like stainless steel or aluminum, not wood or plastic. Insulating barriers should come from high-temperature materials like ceramic fiber or mica sheets. Cables should be silicone insulated, as silicone withstands much higher temperatures than PVC. Every choice of material either reduces or increases risk. Choosing wisely is the simplest form of prevention. Now imagine again. Your magnetic heater is spinning smoothly, magnetic fields interacting, coils humming. The experiment looks perfect. Then a loose cable overheats, insulation melts, and suddenly flames appear. If you have prepared your environment with fire-resistant materials, that flame may smolder out harmlessly. If not, it could spread across your bench and beyond. That moment of difference is what safety planning is all about. Finally, mindset is the strongest safety tool. Fire safety is not just equipment, procedures, or materials. It is an attitude of respect for the forces you are working with. Heat, electricity, and magnetism are powerful allies but unforgiving enemies. Approach every experiment with humility, vigilance, and a plan. Expect the unexpected and be ready to act. Fire safety when experimenting with radiant and magnetic heaters is not optional. It is the backbone of responsible innovation. By focusing on insulation, ventilation, containment, monitoring, overcurrent protection, safe placement, and supervised operation, you can explore the fascinating possibilities of free energy without risking your safety or your surroundings. Experimentation is exciting, but survival is essential. A successful experiment is not only one that generates heat efficiently, but also one that runs safely from start to finish. Fire safety transforms curiosity into sustainable progress, ensuring that your journey into free energy remains a source of inspiration, not regret.